a rule. When you multiply polynomials, so we get to use all these hard words here, together. Anybody remember what a polynomial is? Poly means many, nomial means, I think, terms. So anytime you multiply things, I mean, this is more than just 6 times 7. That's multiplication, it's pretty simple, it's 42, whatever it is. This is a 2-term thing times another 2-term thing. It's many terms, so a polynomial times a polynomial. These specifically are a binomial times a binomial because they're 2-term ones, but this would work if it was a trinomial, which is a 3-term thing times a 3-term thing, whatever. Anytime you come across 2 polynomials times themselves, it's a pretty simple thing. It'll sound confusing, but it's easy. What you must do is multiply every term of the first polynomial by every term of the second polynomial. What you do is multiply every term of the first polynomial by every term of the second polynomial. Really, what it is it's the distributive property on steroids. Okay? Because you are doing the distributive property out to whatever many degrees. Okay? I might write that down because you're the first class I've ever used it with, but it's very true. It is the distributive property on roids. Okay? And that means this, and the biggest problem with this is really keeping yourself organized when you do this. I'm going to rewrite it here so I have a little more room. That means I'm going to take the first term of the first polynomial, this x, has to get multiplied by every term of the other polynomial. So I have to take x times x, and I get x squared. I have to take x times this minus 3, and I get minus 3x. Then, I got to continue on. I already did the first term. Now I have to do the same thing with Mr. Second term there. I need to take this negative 5 and multiply it by every term of that second one. So a negative 5 times x is a negative 5x, and a negative 5 times a negative 3 is a positive 15. I have multiplied every term of the first one by every term of the second one. I did this one first, and I did this one. Now everything has been multiplied. And then I should write down here step number, whatever we're on, 3, because you need to simplify if you can. And if you look at this, what can I simplify? Somebody help me out. Lainey, come on. Is there some like terms? Let's say there are. What's a like? It's like? And what do I get if I have a minus 3x and a minus 5x and I put them together? Minus 8x. So I can put these two, I can join those two together and get minus 8x. This doesn't have any friends, so it stays x squared, and this right here. 2 binomials multiplied together, in this case, give me a trinomial, a 3-termed polynomial. Okay? All right, now, back to the sheet that you have there. Why did I give you that? Okay, because there's, yes, it's kind of a rhetorical question, but you didn't answer. What do you think, Fish?
Does he think it would be the best illustration possible?
Yeah, well, no. No, because what I want you to do right now, actually, let me see if I can pull that up, because it would be by far much more fun if I was looking at the same thing on the board as you do. What do you think I put this under?
Seventh grade something.
Multiplying by.
Yeah, hot dog stand, that would be it. So, I'm gonna guess it's under multiplying polynomials. Here it is, and it's probably under, there it is, lesson 92 FOI. There we go, okay.
I never
Organization
did
skills.
Notice how quickly I found that?
Yeah. Organized.
Okay, here is the deal. Please do this for me. In math, when you get to whatever level of math you are, they won't call this a binomial or multiplying binomials, or maybe they will, but they will say this, you need to do this. Please circle the first letter of each of these 4 words. If you circle those 4 letters, you will come up with the whatever an acronym or whatever that thing is called that says FOIL. And FOIL is just a simple way to remember what you're doing there. If you use FOIL, you've done the same thing that we just did, except it's kind of an easier way to remember it. Notice we did get the x squared, and then we did, it means this. First thing you do is multiply the 2 first terms together, then you multiply the outside terms together, then you multiply the inside terms together, and then you multiply the last terms together. That's exactly what we did, I just didn't use those words. It's the same thing as multiplying every term of the first times every term of the second. But if you think of it in terms of FOIL, you should be able to do these, and not necessarily that I want you to do them in your head, okay? But in FOIL, what happens 99.8% of the time for the problems they're giving you is that these middle 2 terms will always be able to be combined. The first term never will combine with anything, the last term won't ever combine with anything for right now. The 2 middle terms will. Okay, so if I gave you a different one, let's say it was x minus 3 times x plus 8. When you get good at this, you'll just look at that and say, well, that's x squared plus 5x minus 24. Because it's not, it's simple math is what it is. If you think of it in terms of FOIL, the 2 first terms is going to give you x squared. I know my last term has to be negative 24 because it never combines with anything. My middle term always comes from when I put these 2 get put together. The 2 outside terms is what? This and this gives you a plus 8x, correct? This and this put together is a minus 3x. Well, if you have a plus 8 and a minus 3, it's 5x's. 8x's minus 3x's is 5x's. FOIL gets you to this, if you think about it that way, it's just a little faster than doing this times this times this, and then this times this times this, and then combining them. You'll get the same answer, it's just that, they try to make life a little simpler as you think about it, and you get something like that. I mean, I hope they don't give you hard ones right off the bat, because if they do, that would be extremely unacceptable. Yeah, so how about, let me give you another one, and this comes from practice. X plus 4 times x plus 7. Now, in case you're wondering what work do you need to show pitch for this, you gotta write the problem down. And then I would at least do this. First terms give me what? What's x times x? X squared. What's gonna be I like to think what my last term is right off the bat. What's my last term gonna be? 4 times 7 is positive 4 is a positive 28. Then on your paper, I would like to see this. This times this is 7x, this times this is 4x. If I put those together, 4x's and 7x's is 11x. And there's your answer. FOIL. First terms, combination of the outsides and the insides. There's the last term. Cameron Colquitt.
So I'm confused how you got the.
Which one?
How you get the 11?
Alright, once again. Let me write it down here. First, out, inner, last. You understand how I got the first term? X times x is x squared. What are my 2 outside terms multiplied together? What's 7 times x? 7x. What's my 2 inside terms multiplied together? 4x. What happens when you have 2 like terms of 7x and 4x? You put them together. If you have 7x's and 4x's, you get 11x's. Believe me, you're not the, how about this? This comes right out of the book. Now, I would like everybody just to take a moment up here and focus up there. Focus on that. maybe do a little chanting poem. When you see a binomial squared like that, let's hum again. A little red light in your head should go off and say, this is probably not what I think it is. Because most of you are thinking, oh, it's x squared plus 100. No, it's not. How many of you thought it was x squared plus 100? Thank you for that. Good. Your case in point. Okay, that is not what you get if you write this out like it should be. X plus 10 squared means you have two of these times themselves. That's what x squared plus 10 squared means. X plus 10 squared. And if you use FOIL on it, yes, I agree with the x squared for the two first terms. And I do agree with the 100 for the last terms. But if you put the outside terms with the inside terms, what is this? 10x. What is this? 10x. If you have 10x and 10x, you end up with, Keith, 20x's. There, in fact, is still a middle term there. Do I need to hum again at that? So here, let me give you this. X minus 8 squared is not x squared plus 64. What is x minus 8 times x minus 8? Feel free to write it down on your paper. Just so you have a good example there. X squared minus 8 times x, or I'm sorry, x minus 8 times x minus 8. Altenberg, you think you got this one? I'm a little confident on the scale, wasn't I? A little confident, right? That's pretty good. Anybody more confident than a 7? Ooh, you got some confidence. Wow, not very good. Aubrey, what'd you say the answer was?
X squared plus 16x plus 64.
Okay, the only issue I have is the plus 16x. Why? Because here, let's look. I agree, x squared. I agree a negative 8 times a negative 8 is a 64 plus. But if you add a negative 8x and another negative 8x, it doesn't make them positive. Negative 8x and negative 8x is?
Why would multiplying two negative 8s make positive 64 but two negative 8x?
Because always when you multiply two negatives, you get a negative or positive.
adding.
The other one is adding. This is adding. This was multiplying. Multiplying two negatives give you a positive. Adding two negatives give you a big negative, a bigger negative. Got that? Now, just so you can kind of see this a little bit, and I don't know if this, maybe this will help solidify this here. Because one of the reasons the book does this is because sometimes they ask you area things. If I have x plus 1, and I am multiplying by x plus 3, if I were to draw a visual of that, let's say let's say this was two areas of a rectangle, two sides of a rectangle. Well, here's what the deal is. If I had this, here is x plus 3. Let's say my x stops here, and then I add 3 more to it right here. So here's my x, here's my plus 3 part of my rectangle. And then here is my same x, which is the same distance on the other side, except this time I'm adding 1 to it, which only goes about to here. So now I have x plus, let me do it here. I have x plus 3, 1, 2, 1, 2, 3, right? X plus 3 units. And this one I have x plus 1 there. Yeah? Does that kind of make any sense here? Let's look at it. If I had this as my rectangle, here's my x plus 3 things. Here's my same x, which would be the same length, plus only 1x. And you took all of these areas and added them together. What is the area of this square here that's formed by x and x? An x squared, right? What would be the area of each one of these if it's 1 times x, 1 times x, 1 times x? Each one of them would be x, right? 1x, 1x. What would be the area of this? This is x, and this is 1. It'd be another x, right? And then what would be the area of this? 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. If you put all those areas together, x squared's by itself because it can't combine, there's no other x squareds, okay? But here I have x plus x plus x plus x, which is 4 x's, and here I have 1 plus 1 plus 1, which is 3. Is that what we get if we multiply these two binomials together? Well, FOIL, F-O-I-L, first term, x squared. Outside term, 3x, inside terms, 1x, 3x plus 1x is 4x, and my two last terms give me 3. Now, if you didn't get this, it doesn't matter. You just have to understand I need to use FOIL. But this is kind of the visual about why that works. Because they will ask you to do this. Give me the area of the rectangle. And you don't have to draw all the little squares, but if they say that this is x plus 2 and this is x plus 8, to find the area is length times width, you're going to have to multiply x plus 8 times x plus 2. In which case you'll have to use FOIL, which gives you, anybody fast enough to do this real fast, do you think? Right, Harrington's got it. Ooh, the smoke is rising up. What'd you get?
X squared.
Yep. X squared is right. How about your last term?
8 then.
8 times 2 is 16. I always like to do the last one because the middle one's a hard one for me. What do you get when you add the outside term, 2x, and an 8x together is 10x. That's the area of this. You have to put whatever it is, inches squared. Again, it doesn't make any sense because they're not actual whatever numbers, but wow, that's like information overload. Oh, I guess we have to do one more. I hate to run out of time here. Do this one real fast for me, tell me what you get. Or do it real slow and concise and tell me what you get. Try to get the right answer and tell me what you get, I should say. FOIL. You could say rats foiled again. This emails have been out of control. Think about FOIL, first, outer, inner, last, combining the outsides and the insides. Isabel says,
X squared minus 1.
let's see. First terms, x times x is x squared, correct? Outside term is a 2x, inside term is a minus 2x, and the last term is a minus 4. And yes, these become opposites. They go away, there's no x's left. If you have 2 x's and take 2 x's away, they're gone, and you are left with just x squared minus 4. Like we say in my business,